My name is Toral. I'm here with Juan Suarez and Canal. We work for Igalia, and we're going to talk about some of the ongoing work we are doing on the Raspberry Pi driver stack. So this is what we are going to cover. When I initially thought this presentation, it wasn't clear that the Raspberry Pi would be announced by the time of XDC, so it wasn't there, but it would be really weird having it announced just a few days ago to not come here to talk about the driver stack for Raspberry Pi and not talk about Raspberry Pi 5. So I'll have a brief mention to that. And then Juan is going to talk, well, I'll keep talking a little bit about the CPU job handling on the Vulkan driver, which is a kind of continuation from the talk we had at the previous XDC. And then Juan is going to talk about desktop OpenGL 3.1 support on the driver and the caveats with that. And Mayra is going to finish talking about how we expose GPU stats for user space. So Raspberry Pi 5, it's based on the same architecture, the video core architecture from Broadcom. It's just a new iteration of that. It comes with a higher clock rate, so it's able to do a bit better on graphics. It also comes with a few extra features, like we have 8 render target support, we have better support for subgroup operations, and maybe from the driver perspective, the major change was they made changes to register files and the instruction encoding so they can do more instruction level parallelism. So that allows us to basically produce smaller shaders that can run faster. So the driver status is we just landed most of the work for the Mesa side of this just a few days ago. And there's still a few patches for some specific optimizations that require changes in here, and those are on review. And then we have some patches on the kernel, which I need to send a V2 for those, hopefully soon. And then the feature level that we're exposing here is the same as for Raspberry Pi 4 currently, so that's OpenGL 3.1 and Vulkan 1.2, although, as I said, we do have some extra bonuses here. And then we also expose non-conformant version of OpenGL 3.1. This is also for Raspberry Pi 4, well, Juan will talk about this a bit more later. Okay, so that's it for the Raspberry Pi 5 stuff. Now let's talk about some of the work that we have been doing outside Raspberry Pi 5. And one of these is, if you had been at XDC last year, one of the pain points that we had in the Vulkan driver was that this view that Vulkan has where everything executes on the GPU is not really how it happens for Raspberry Pi. So we need to have some level of CPU participation in some things. And the way we were handling this in the driver was really terrible because it required, it was basically all handling the CPU in the user space side, and this caused some problems. Particularly, we couldn't implement things like syncFD exports and things like that because of that. So the way we have been handling this is twofold. On the one hand, there are some things that we push to GPU through compute shaders, and this is the case for event handling now for us. And then for things that really require to use the CPU, like for example, timestamp queries, Mayra has been working on implementing a new type of queue on the kernel, which is a CPU queue, and basically just executes tasks and jobs on the CPU, but it does that from within the kernel, which means from the user space driver point of view, it is just another queue, and there's no difference. We can still use sync objects, and like we can coordinate all our work like we do for everything else. And this allows us to expose syncFD now. And now Juan is going to talk about OpenGL 3.1.
Yeah, so OpenGL 3.1 for Raspberry Pi 4. First thing is that we expose OpenGL 3.1, but we are not conformant. And probably won't be conformant, at least for the Raspberry Pi 4. And reason is because, well, this requires some features in the hardware that we don't have. But still, we have quite a large number that allows us to implement all the required extensions and things to expose OpenGL 3.1. And why this is important? It's important to expose OpenGL 3.1 instead of keeping the 2.2. And main reason is that the Raspberry Pi devices intended to be used as desktop host computer. And so most desktop apps are tried for the OpenGL desktop instead of OpenGL ES. And the thing is that we were already implementing a lot of the features required for the OpenGL 3.1. So only a couple of them were missed and well, it was a matter of time to implement them. So that makes me sad to expose OpenGL 3.1 for Raspberry Pi 4. And well, you know, when you expose a new version, there appears new tests, new failures, and we were working on the on fixing all the CTS fails and also impil it. So for CTS, we managed to fix all of them. For impil it, almost, except some that I will talk later. But still there are quite a lot of tests to fix because, you know, there was like a lot of tests that were skipped because they require OpenGL 3.1, especially tests for some extensions, and now they are uncovered and well, some pass, some fail, so we need to analyze them. So for the failing tests, we identify like they were failing due three kind of features we don't support in the Raspberry Pi 4. One is of course the 8 render targets, or however only support 4. But I think it's the same for other drivers like FreeDreno, probably Panfrost, they only support 4. The funny part is that MISA is lying here, like white lying, in the sense that they know that 4 is enough. So they just, okay, say it's 4 is support, then we expose OpenGL 3.1. The good part is probably this will be fixed, I mean, it's probably nice. It's fixed in Raspberry Pi 5. They support 8 random targets. The other thing that was missed was support for the 16 bits formats for texturing. We support this format for other things, but not for texturing. Fortunately, this is kind of easy to fix because MISA there is like this a fallback mechanism. So if you just say that you want to support this format for anything, we'll fall back to other formats that are supported. And with this, basically, we managed to fix all the problems. And the last one is a bit annoying, but is that in OpenGL, the filtering, texture cube map filtering is non-seamless, and OpenGL ES is seamless. And our hardware is intended to be used by OpenGL ES. So basically, it does the seamless filtering by default, and you can't enable it non-seamless. So we are not sure if this can be fixed in the Raspberry Pi, but we were thinking about doing maybe trying some kind of lowering to convert QB maps to array of textures. I'm not sure if Sync is doing something similar. I guess so. So it's something that we need to explore to solve this problem. So that's the situation. So now, Mayra.
Okay, so the last most important feature that we introduced to the Raspberry Pi driver stack recently was GPU stats. We exposed them globally and per file descriptor. And due to some hardware limitations that we have on the Raspberry Pi, we ended up using a CPU resource to calculate the accumulated amount of active time, because we don't have a way to do this in the GPU. So we ended up using local clock to calculate the accumulated amount of active time. In order to expose the GPU stats per file descriptor, we used the standard DRM client usage stats. So it's something that we have in the DRM already, and it's pretty standard, and you can integrate it with GPU top in IGT, for example. And for the global GPU stats, we don't have something standard yet, so we used sysfs to expose the global GPU stats. Here you can see GPU top running on the Raspberry Pi 4. So as you can see all the queues on all the 5 queues that we have on the Raspberry Pi 4. And you can also see we using the global GPU stats in the UI. We implemented like on the task manager, which is right on top there. And you can see that we exposed the global GPU stats.
Yeah, so that's it for this presentation, and now if we have some time for questions, if you have any.
You mentioned in your talk that there are some missing hardware features that prevent you from supporting GLES 3.1. And I'm just curious, does that have any implications for Vulkan support?
So it's not GLES, it's desktop GL. And for Vulkan support, what do you mean? I mean, like in Vulkan,
so the missing hardware features, do they prevent you from supporting Vulkan?
No. Vulkan, we support up to 1.2 at the moment. I don't know if we can do 1.3. I guess we'll get into that from now on. But that was only strictly affecting OpenGL.
And my second question.
Vulkan is actually a bit nicer in that regard because there's a lot of optional stuff, and GL is more strict with these things. There's a lot of things packed into a core version, and if you don't have one format that you don't support, then you are screwed.
So my second question is, do you have any plans for supporting Vulkan video?
Not at the moment.
Thank you.
Hi. As I understood, both global and per application, per 3D application stats are supported now. Can you tell me more about how these stats are collected?
So we basically collect the timestamp when we queue a job, when we start to execute a job on the GPU, and when the job finishes, we will have an interruption, and then we collect the timestamp again, and then we make the subtraction.
Thank you.
No more questions? I think we're done. Thank you.